Hello everyone, this is another exercise video, and in this video I want to design something that has a purpose, some kind of everyday use product, and I want to intentionally make it a bit complicated to be able to cover some of the features we talked about in this tutorial and maybe include some of the features that we haven't talked about yet, but I thought it would be a good preview of what's coming in the tutorial. And disclaimer, there's so many ways to design this part. I'm intentionally going to design it in a way that allows me to use those features. So you can, of course, use different methods to design the same part. And please feel free to share that in the comments, and we would love to take a look at it. So in this design, we're going to design a planter pot. It's a product that has a purpose, and it can be just a simple bowl, and that would take only seconds to design. But we want to design it something more like a decorative product, something that can be used as a accessory, like a decoration piece. People use it at home, or people, you can see those kind of products in doctors' offices and waiting rooms and kind of like that. It kind of gives it an elegant look. But that kind of product would also be 3D printable. It would be small, a single piece component, so you can kind of do the same thing. Follow those steps in this video and then create the STL file and print that kind of planter pot at home with your own 3D printer. So let's start a sketch, and let's use the 2-point center rectangle. First, let's select the XY plane. Let's use the 2-point center rectangle. That way we take advantage of that symmetry. Right, dimension this. Right now my measurement units is set to millimeters, but I want to design it in 4 inches. So I manually typed in 4IN. And to dimension this side, I don't want to manually enter it. I'm going to use this parameter. That way it updates every time I change this dimension. Now it's a perfect square. I finished the sketch because it is fully dimensioned, fully constrained. And now I go to 3D Model tab and I can apply a modeling action to it. So now I select again this square and enter 4 inches. It's a 4-inch extrusion. Now it's a perfect cube. This extrusion now, it's sitting on the XY plane. So now that's how I want to design it so that I can take advantage of the symmetry. I can take advantage of the axes as well. So I want to I want to add a sketch on this view here, but I do not have a surface to work on. I have this left view, I have this bottom surface right here, but I do not want to work on those surfaces. I want to work on a surface that is normal to this view. And I do not have that right now. Therefore, I have to create my own custom work plane. I will click on the plane. So let me hit escape on my keyboard and click on plane, select this edge, and then select this edge. And I have a work plane in the middle of that cube. Now I can create a sketch on that work plane. And I want to, create a sketch, but right now this material here is in front of me. And in the previous videos, we talked about this trick. You can you can press F7 on your keyboard in your sketch mode, in the sketch mode. That is going to remove all the material in front of you. So you can, see the sketch you are creating. Instead of drawing lines and everything, I want to project geometry and take advantage of the existing 3D object. And that way I can use those edges and corners as a reference. So now I created and I projected these geometries here, and I'm going to draw a line starting from the bottom horizontal line to the vertical left line. Now I want to dimension that. This point to this point is 40 millimeters. This point to this point is also 40 millimeters. And now it is fully defined. I want the same line also at the top, but instead of drawing another line there, I want everything to be linked and I want everything to be symmetrical. So I want to use maybe a construction line here. This green dot indicates that it is going to be constrained to the midpoint of this vertical line. I draw this line here and click OK and get out of that command. Select this line and convert it to construction line. Now it is a reference line that I can use to maybe use the mirror pattern. I'm going to click on mirror and select this line that I want to mirror. And as the mirror line, I want to select the construction line and say apply. Now I created this line at the top that is a function of this line at the bottom. So if I, for example, let's just click on this and use this parameter. Now, if I click on 40 millimeters and change it to say 30 millimeters, this dimension changes because it is using the parameter. It is using the this line as a reference. And also, since this line at the top is the mirrored version of this bottom line, that updates accordingly as well. So let's just go back to 40 millimeters again and finish the sketch. Now we still cannot see the sketch we created because now the cube, that material that we've temporarily removed, is back and kind of blocking our vision. And we will extrude that. We can still highlight it. Let's select that sketch at the top and bottom. Right now it is adding material, but we can use the extrude feature to cut material as well. We will talk about the extrude feature in the following videos in more detail. Let's do it symmetrical, and let's do through all. That way it cuts everything on its path. Now we created this shape on this edge of the cube, and now we want to apply this to on all four edges. So we have the circular pattern here that we can use for that. We cover the patterns in sketch mode. We can rectangular pattern or we can circular pattern the sketches we generate. But at the same time, in the 3D model tab, we can also create patterns of the modeling actions that we implement on the design. So we can select a circular pattern, select the extrusion we just created, and then as the rotation axis, we can take advantage of this Z-axis in the middle of the cube. It is right now creating 6 counts of the extrusion we did. So let's go back to 4. That way it is applying that extrusion to all four corners. And now this work plane did its job. I don't need it anymore. I will uncheck the visibility so the design looks more clear and I can kind of look at it. It looks symmetrical, this 3D object, and now we can shell this object. And we can select this top side, and that's our opening. Shell feature is something also we're going to talk about in more detail in the following videos. This is basically removing the material to create this hollow cavity. And we selected this top surface, and so now the inside of the 3D object is just hollow. And we changed the thickness to 3 millimeters. That way the wall and the outer wall is 3 millimeters thick, which should be sufficient if you want to make this out of plastic. So now the planter pot is technically done, but these edges and corners are still too sharp, and maybe we want to use a more smooth design. And fillet feature is something also we're going to cover in the following videos. So let's, I don't know, maybe 15 millimeters of diameter. I would love to select everything, but that's not going to apply a fillet on everything here in this design. I'm just going to select this portion here, right here, and do that 15 millimeters down. The reason why I didn't want to apply 15 millimeters here is because there's not much material here on this section, so it's going to give me an error if I try to apply a 15 millimeter diameter here. So let's apply, say, 1 millimeter diameter to those edges right here, and then 1 millimeter on the outer edges. Done. So now we can apply maybe 5 millimeter diameter, 5 millimeter to the bottom side. Done. Technically, the rule of thumb is you design what you want to design, and then as the final, the action, you do the fillets and chamfers. But right now, this is just an exercise, and the planter pot is done. But let's add drainage holes at the bottom because these planter pots also have some drain holes at the bottom to remove the excess water. Let's look at it like this and draw a circle here and then dimension that 4 millimeters, 3 millimeters maybe. And this dimension, this distance between the circle and the edge is 10 millimeters. Let's say here is also 10 millimeters. Now we can do a rectangular pattern here. Select this hole, and the first direction is this way. Second direction is right now it's the wrong way, so we're going to flip it. Let's add 5 here, and click OK. Now we added all these circles. Let's extrude these. Let's finish the sketch first and then extrude it. We're going to cut through all. Let's select this, and Yeah, so we're just selecting the holes so that this excess water can drain through these holes. It doesn't stay on the planter. Almost done. Done. So we're going to cut. Sorry, I was accidentally adding material. We're going to cut these and done. So we can even like add standoffs here. So let's do another sketch here. Maybe project. Let's undo that. Project this surface here. Maybe draw a line here. Draw a line here. Draw a line here. And then let's trim that additional line that I created there. And then click on this with the control key pressed on my keyboard. Let's make that parallel to this line. Let's make this parallel to that line. And then let's make these two equal. And then let's dimension it to fully define it. 4 millimeters. Let's dimension it like this. So let's add a reference line here, like that, a construction geometry, and then constrain it here. And then make this 4 millimeters. And then this length here is, say, 4 millimeters here. Now it is fully defined. So now let's do a circular pattern for that. Select this line, this line, this line around this midpoint. And then we want 4 of them. Click OK. Now we created these triangles on all 4 corners. Let's finish that sketch and let's extrude that. This here, this here, this here, and this here. And now we're going to do that 3 millimeters only. Click OK. Now we have this standoff. Let's do a fillet. I mean, might as well. So do this, do this, do that, do this, do this, do that. Okay, yeah. Yeah, so now we have this planter bowl. Right now it looks too, it has the edges, so let's go to visual style and change it to realistic. Now this smooth looking, symmetrical, kind of decorative planter bowl that we can use in a backyard, in our home, or in an office environment. And some kind of a cactus can be planted in it. But this would have taken a lot shorter. I'm trying to explain everything. And again, there are so many different ways to do this. And we're just intentionally doing it this way to cover the things that we talked about in the tutorial. And please go ahead and try it at home. And you can always change the design. You can use different dimensions. That's going to change the shape. And I did it 4" by 4", so that would be easy to print. And go ahead and share your experience with it. And we're going to continue to do more exercises like this. And I'm going to go ahead and share the STL files under the videos at some point. I can even just 3D print this and make a video of the result as well. But let me know what you think in the comments too, and don't forget to subscribe. I'll see you in the next video. Thank you.